The word problem in example 4 is just like the ones I've assigned in 24 and 27, and they are just like example 3, except with real data. So the data that they're using in example 4 is actual data from the breathing rate of cyclists being compared to the speed of the cyclist. In other words, how does it depend on the speed of the cyclist? As a cyclist goes faster in miles per hour, are they breathing more, and what kind of a relationship is that? Is it linear? Is it exponential? Is it quadratic? So the X values are in miles per hour. And the data was taken between 20 and 25 miles per hour for the X value. So I'll just put the end, this is miles per hour cycling. And the Y values are 51.4, and this is liters per minute of air breathed, or breathing rate. So 51.4, 57.1, 63.3, 70.3, 78, and 86.6. So our first step, just like we did in the last problem, is to determine, is this data linear? Is it exponential? Is it quadratic? Well, looking at it right now, is it linear? 51.4, 57.1. There's a difference of 5.7. And if between the next two, so the first difference, right? Let's see, is plus 5.7. And let's see, and then 6.2. So clearly not linear. Could be quadratic. Let's see. So that's the first differences. And the second differences look here like it's right, plus 0.5. And this is plus 0.8, plus 0.7. So not quadratic, not linear. The first differences said not linear. The second difference said not quadratic. So it's pretty likely that this is exponential. So let's see what it multiplies by. If we divide, let's see, 57.1 by 51.4, we're going to end up with 1.11. Let's try 63.3 divided by 57.1. The next two, and if we divide those, we also get 1.11. So we find that, and I can't reach all the data points up there, but as we go through each data point all along, it's going to be times 1.11. So it's actually exponential. So we've now determined what kind of function it is. So we have the first part of the problem. The second part of the problem is what we did before, and we need to determine what is the actual equation. Well, the equation itself, the base equation, is y equals a times b to the x. And as we did in a previous problem, I believe we did example 3, guided practice 3 and 4. Actually, example 3 we found was also exponential. And if we pick one of these points, so we'll pick the ordered pair 20 and 51.4, and we plug these values in for y and for x, we can get the a value. So if y is 51.4 equals a, which is what we want to find out, and we know that b, by the way, is 1.11. Okay, that's our factor for the exponential equation, and x up here is going to be the 20th. So just to go back, since we determined that each of these is increasing at a rate of times 1.11, this becomes the value of b, and we're left with needing to find a, because once we have b, and we have x here, and we have y, we can plug each of these things into the equation to find a. And just to make sure we're clear, this is where b goes, this is where y goes, and this is where x goes. And b equals 1.11, x equals 20, and y equals 51.4. When we enter all that information, we find out that a equals 51.4 divided by 1.11 to the 20th power. And so when we work that out on our calculator, we find out it's about very close, if you round, to 6.38. So having done that, our final equation is going to be y equals 6.38 times 1.11 to the x. Okay, so this is the type of problem you're going to encounter in lesson 24 and lesson 27. In both cases, you have to find whether it is, what kind of function it is, find the equation, and in the case of number 27, then using the equation, they will ask you to plug a number in and find the answer.